Good morning, students. Chapter 7, System of Particles and Rotational Motion. Yes, in last lecture we have discussed about center of mass of rigid body, how to find center of mass of rigid body having symmetrical shape and if it is having irregular shape. Okay. Now, in next session we will see mass distribution. Okay. Yes, objects having mass may be of three types: one-dimensional object, two-dimensional object, and three-dimensional object. So yes, for one-dimensional object we have to define one quantity, that is linear mass density, that is mass per unit length. For two-dimensional object we have to define surface mass density, and for three-dimension that is density mass per unit volume. Okay. So yes, now we will see this topic. What is title? First, mass per unit length. Mass per unit length. It is also called linear mass density. Linear mass density, which is indicated by lambda, and it is indicated by lambda. Linear mass density. Linear means it is used for one-dimensional object. For one-dimensional object. Okay. For one-dimensional object, let it is one-dimensional object having some length. Okay, having some length. Let its length is L and its mass is M. Its length is L and its mass is, suppose it is M. Okay, let length of wire is L and mass of wire is M, and mass of wire is M. Clear about this? Total length and total mass. Total length and total mass. Then mass per unit length is defined as a mass per unit length. Mass per unit length is defined as total mass per total length. Total length. Mass per unit length means total mass per unit length. How do we represent it? Lambda is equal to it is M upon L. Lambda is equal to it is M upon L. Simple. So yes, it is mass per unit length, linear mass density. Okay. Now what is use of this linear mass density? See, this M is mass for this total length L, for this total length N. And if I give you one question, okay, what is mass of only this element? Yes, it is your question. Okay, what is mass of this small element? Yes, what is mass of this small element? So yes, how to find? If length of this element is dx, okay, if length of element is dx, then mass of element d and is equal to it is lambda dx. Now you may ask me one question, sir, how lambda dx? One simple relation. What is lambda? What is lambda? It is mass per unit length. Means if I have unit length, mass is lambda. See, what is meaning of this? Mass per unit length is lambda. Means I have unit length, then mass is lambda. Now for dx length, what is mass? Yes, it is lambda dx. So yes, you have to remember this equation. It's simple. Okay? Yes, if length of element is dx, then mass of element dn is equal to it is lambda dx. Simple about this? Okay. So yes, it is mass per unit length for one-dimensional object. Now next quantity is, yes, next quantity is, it is surface mass density. Surface mass density, or you can say mass per unit area. Mass per unit area. And yes, it is mass per unit area denoted by sigma. It is denoted by sigma. And yes, area means for two-dimensional object it has area. So yes, it is for two-dimensional object. It is for two-dimensional objects. Okay. Now, if I have one plate like this, I have one plate like this. Okay. So for example, it is one plate. It is one plate. So yes, I can assume let mass of plate, total mass of plate is m, and total area of plate is a, and total area of plate is a. Then yes, like this, as it is mass per unit length, how to write here it is mass per unit area is equal to total mass is equal to it is total mass divided by total area this total area. Mass per unit area is equal to it is total mass divided by total area. So sigma is equal to it is mass upon area. Sigma is equal to it is mass upon area. Simple. Yes, sigma is equal to it is mass upon area. Okay. Now again, what is use of this? If on this square plate I have one element like this, I have one element like this having area D. So if area of element is D, if area of element is D, then mass of element dm is equal to, yes, it is sigma d. Again, yes, again that relation. Okay, mass per unit area is sigma, means area is unit, then mass is sigma. So for dA area, what is mass? Yes, it is sigma d. So yes, in this case, lambda is equal to m upon L and dm is equal to lambda dx. In this case, sigma is equal to m upon a, dm is equal to sigma into dA. Now third case, I think you know, it is about density. Yes, it is about density. See. So now third one that is volume mass density. And yes, I know, and you also know this condition. Okay, or it is called mass per unit volume. It is mass per unit volume, which is indicated by rho. And yes, it is for three-dimensional object. It is for three-dimensional objects. Okay. So yes, volume mass density, that you know. Okay, for this let we consider one object like this. Okay, so suppose it is one cube. Okay, three-dimensional object. Okay, that its total mass is m. Its total volume is V. Okay, its total volume is V. Then what is mass per unit volume? Yes, mass per unit volume. Mass per unit volume is equal to it is total mass per total volume. Simple. So yes, you know that equation, that is rho is equal to it is mass per unit volume. Rho is equal to it is mass per unit volume. And yes, you also know its use. Okay, if I have one element like this having volume dV, Okay, if volume of element is dV, if volume of element is dV. Okay, so therefore mass of element mass of element dm is equal to, it is rho dv. Clear? So yes, these 3 points you have to remember. Okay, what is mass per unit length, mass per unit area, and mass per unit volume, and mass per unit volume, lambda, sigma and rho, that you have to remember. Okay, now we will see some uses. Now we will see some uses of these 3. Okay, and particularly for this first one, okay, what is use of linear mass density, how to solve some questions based on it. Okay, we will see now. Now next question is, see, center of mass of thin rod with uniform density, with uniform density. Okay, how to find this question? First of all, we will assume, yes, what is thin rod? Yes, let it is thin rod. Yes, it is thin rod. Okay, yes, it is thin rod. Okay, let we are assuming data for thin rod, let total mass of rod is m, and total length of rod is l. So yes, whenever you are given one-dimensional object, then find its mass per unit length. That is mass per unit length. Lambda is equal to m upon l. Now you have to find where is center of mass of this rod. For that, see, we are assuming that this one end is at origin. This one end is at origin, that it is y-axis, and that it is x-axis, and that it is x-axis. Okay, let one end of rod is at origin. Let one end of rod is at origin. Simple. It is at origin. It is at origin. And yes, we know that this length is L. This length is L. Simple? Yes. Okay. So yes, one end is at origin. One end is at origin. Now, yes, as it is a rod, and we have to use what is method, how to find. We are dividing this whole wire, this whole rod in very small elements, and I am taking one element like this. Okay, let it is one element on rod. Let it is one element on rod. Okay, okay, let it is one element on rod. It is one element on rod having length dx at distance x, from origin. At distance x from origin. So take one element. Take one element. Take one element at distance x from origin. Take one element at distance x from origin. Yes, length of element is dx. That yes, I have indicated. Okay, so what is mass of element? Yes, mass of element dm is equal to this lambda dx, or you can write it is m upon l dx. Simple. So yes, again, what is method? First of all, divide the whole object in very small elements. Okay, in very small elements. Take one element at a distance x from origin. Length of element is dx. So what is mass of element? Yes, is equal to this lambda dx, means m upon l dx. dx. Now see, in last lecture for center of mass of rigid body we have obtained one equation, okay, that r center of mass is equal to integration r dm upon integration dm, and yes, it's three components: x center of mass, y center of mass, and z center of mass. Here, as object is linear and it is only in x direction. Again, as object is linear, thin rod, okay, as object is linear, it has only x component because it is on x axis, okay. So yes, here thin rod, we can consider as one-dimensional object. And as it is placed on x-axis, okay, the center of mass of thin rod with respect to origin O, x center of mass is equal to, what is equation? Yes, you know equation. It is integration x dm upon integration dm. Yes, you know this equation. It is integration x dm upon integration dm. Yes or no? Yes, it is. Okay, so now how to find integration x dm and integration dm? How to find integration x dm and integration dm? I will find these two things separately. See, integration x dm is equal to integration x. What is value of dm? Here it is m upon l dx. Simple. Yes or no? Yes, it is. Is equal to mass constant, length constant, so it is integration x dx. Now you have to put limit. See, I have considered only one element. In actual, we have to divide this whole load on small elements. So one element, second element, third, 4, 5, 6, dash elements. Yes or no? And see, these all elements are between these two ends. These all elements are between these two ends. Yes or no? So yes, first end is at origin, another end is at distance L. So what is limit of x? It is from 0 to L. Again, limit means elements are between which two ends? Between these two ends. And with respect to origin, see, what is distance of this point? 0. What is distance of this end? It is L. So limit is from 0 to L. So yes, is equal to, it is m upon L. X dx, what is integration of x with respect to dx? It is x square by 2. Limit is from 0 to L. So now we have to put limit. It is ml. Here it is x square. Sorry, you have to put upper limit minus lower limit. Okay, first of all, this x is replaced by L. So it is L square by 2 minus 0. Okay, so 1L cut. So it is equal to, it is ml by 2. It is ml by 2. Simple? Yes or no? Yes, it is. Now we will find what is integration dm. Integration dm is equal to integration m upon L dx. Again, m upon L constant, integration dx, that is from 0 to L. Again, it is from 0 to L. Is equal to, here it is m upon L. What is integration dx? It is x. Limit is from 0 to L. So is equal to, it is m upon L. And here it is L minus 0. L cut. So it is only m. So it is only m. Clear about this? Okay. So now, yes, last step. What is last step? X center of mass is equal to, yes, x center of mass is equal to, what is it? This answer of integration x dm is ml by 2. It is ml by 2 divided by integration dm, it is mass. So ml cut. So yes, what is x center of mass? X center of mass is equal to, it is L by 2. X center of mass is equal to, it is L by 2. And L by 2 means, yes, exactly at its midpoint. It is center of mass at its midpoint. Okay. So if object has uniform mass density. If object has uniform mass density, then its center of mass is at its geometrical center. If object has uniform mass density, okay, its center of mass is at its geometrical center. Okay, if object has uniform mass density and symmetrical shape. Okay, then its center of mass is at its geometrical center. So it is when used of this linear mass density, how to find center of mass. Clear? So yes, for today's lecture, this two theory is enough. This is it for today.